this presentation actually supposed to presented by one of my students, but she is not here. So the title is a bit complex, but I will try to make it simple for you. So I will just start, maybe summarize what we have done so far. So most of these knowledge graph, especially automatically generated, if they use NLP, usually it contains some kind of noise. And the idea is basically detecting this noise and try to basically remove or improve the quality and make a better knowledge graph for the downstream task. We focused on SKOS-based knowledge graphs. So we try to focus on this type of knowledge graph. And the idea is basically use some kind of link prediction model using embedding and try to detect the inconsistent relationship. For that purpose, we use SemOpenAlex, which is a kind of knowledge graph for scholarly publications. Okay, so let me start with a motivating example. Most of us basically try to look for on the Google Scholar search for some papers, do some literature search. And if you basically have some keywords, that's nice, like link data, and then you will see some other maybe relevant searches. But if you forget the other keywords, like for example, if you just search with the link data, probably you will have less result. But if you search with RDF data, you have a better result. And SemOpenAlex actually kind of a good knowledge graph which try to categorize these relevant related concepts. And if you search for link data, you will see also some other relevant searches. But since this SemOpenAlex knowledge graph created kind of semi-automatically, and they use NLP to generate this what they call concept hierarchy. So SemOpenAlex contains the papers, but also there is a good knowledge about how these concepts are related to each other, and they try to use SKOS-based vocabulary to categorize this knowledge. This is basically called concept hierarchy. So we will be focusing on this concept hierarchy. We try to improve the quality of this concept hierarchy, and we just try to play with this concept hierarchy. We figure out basically there are some problems, and obviously we ask the owner, why do we get this result? And they explain because it's NLP generated. And simple example, for example, this polycystic kidney disease categorized under the kidney as a broader. And we know that this is not correct. And we try to think how we can improve this kind of, how we can improve this vocabulary. And we come up with a strategy. We first look at the definition of SKOS, and we find some way to basically detect this. But before that, maybe just try to summarize related works. Most of work is basically using either rules. If you are lucky, then you can try to use this kind of rules to improve your knowledge graph, or they use some graph structure to come up with a better way to learn the representation and use link prediction to improve the knowledge graph. So what we did, we try to use combination of this inconsistent definition and integrate an embedding model where we can predict the correct one. Okay, so overall approach, basically you provide the knowledge graph as it is, and then learn embedding model and see if this embedding model can help to detect the best link or the correct link. So let me try to give you more about the embedding model. So typically embedding model takes a knowledge graph as a kind of triples, and then try to start with a random embedding for each node and relation representation. what you see, there are different components, but most of time you define a scoring function, and with that scoring function, you calculate the loss. With that, you optimize this embedding representation. You basically come up with the vectors representing the knowledge graph with this definition of loss function. So, but there is a maybe I should go back. There is a slightly different thing. You have to also provide some negatives. So each triple is positive, but you have to create these negatives, which means basically you either randomly generate these negatives. Sometimes it's true, sometimes not. We try to focus on that. So we basically know that there are some inconsistency in the knowledge graph. We detect this first, and we provide this inconsistency definition to generate random or negative samples. Instead of random, we also generate some negatives based on this inconsistent definition. And then representing this embedding model to predict the link that is supposed to be correct. And we evaluate this based on basically simple link prediction model, but also we know that we have to find the correct link. And we use an external data set to validate our result. We use UMLS concept hierarchy to find the correct link. Okay, so if you look at the SKOS vocabulary, especially SKOS is kind of maybe not very formal vocabulary, the representation, you will see in the page there are some definitions that how you should use the vocabulary, and they describe inconsistency definitions. And some of them is basically two of them which was relevant for us. One, for example, is saying that if you define a relationship between two concepts, you shouldn't do it shouldn't be related and broader at the same time. And this was kind of some free text format, so we try to formalize in a first order logic, and based on that we detect those inconsistent triples. So as I said, one of them is basically if you try to define something like human is a broader of mammal and human is related to mammal, so you should pick one of them, not both. The other rule is a little bit complex, but kind of doing the same thing. It just assumes that if you have a human broader relationship mammal, and you also define human related to bird, so if you have another triple which says human broader than bird, then you can actually have this broader definition from human to bird, and then you have the same situation with the first case. So it creates another inconsistency based on the first one. So basically, we now define this inconsistency, and the way we use this inconsistent definition to generate negative samples. You take the positive, and then use the constraint and generate another triple. Simply, if there's a related, you generate a broader definition, broader relation, and it will be inconsistent triple for us as a negative. Okay, so as I said, we have done this so far, but we really want to assess with the external validation test set. So we try to look for other knowledge graph, other data source, and we find UMLS basically contains somehow similar concepts. So we try to first match those concepts that we found in the SemOpenAlex. So to do this matching, we do a kind of sync similarity using Levenshtein distance with threshold 92 to find these matching concepts. And that is basically for us a kind of external validation test set. So this is some statistics, how many constraints we find for constraint 1 type, constraint 2 type, and the matching concepts. And then we also, as I said, we have external validation set, but also we try to do normal link prediction, which means basically you remove some of the links in the knowledge graph and you try to predict. Doesn't matter if the relation is correct, incorrect, but we call it is proving tested. So the result is basically if you don't care about which link is correct, and you do remove some links from the knowledge graph, and you could basically try different this strategy, sampling strategy, negative sampling strategy. One of them is without sampling, negative sampling, or you use random sampling. The other thing is the one that we proposed. If the knowledge graph is already noisy, we see there is not much improvement with our proposed negative sampling. As you see, there are different methods. We use trans-E, dist-mult, even graph neural network, and some fancy method quad-A. Basically, this proposed negative sampling didn't work if you don't know exactly these the triples that you put in the test are correct or incorrect. But if we look at the result where you know the correct triples based on the external validation test, we see much improvement. Basically, if you use, for example, the quad-E, almost you have perfect all the time. You can find the perfect right link. And this is encouraging because we were trying to find better way to revise the knowledge graph and find which one is inconsistent. So we haven't done really like the testing different sampling strategy here, but at least that shows us that this method can learn the right embedding strategy and detect which link should be removed. So there are, of course, some problems in our work. We didn't try different, so we try to only focus on a sample of knowledge graph because of this knowledge graph is very big. So we want to try different experiments with different sample size, but also different negative sample. Currently, we just focused on two kind of negative sampling strategy or constraints. We can even increase this and use different sampling strategies. And maybe more importantly, if we know some maybe oval-based knowledge graph, we can use oval constraints or rules that help us to generate this negative set. And the future, basically, if we kind of know how to iteratively improve the knowledge graph, so you can ask this to the domain people, so the one that needs to be removed or added, and you can come up with an iterative approach to basically enhance your knowledge graph. That is the future work that we are thinking. And thank you for listening. I'm happy to take your questions.
I have a question in the meantime. So you've looked specifically at these kinds of inconsistencies. Do you have a feeling, have you already started to look at the other kinds of inconsistencies that you might want to model next?
Yeah, so for example, we know that oval has some inconsistent definition, like a disjointness, right? That could be one thing. And there are some domain dependent, like basically, you know, if you have an ontology. Currently, we're also working with family ontology. We define some rules. And that could be something we can learn from rule mining, maybe.
Okay, thank you. Oh, question there.
Thank you, Ramzi. I'm not sure I understood correctly. I think that I understood that when you are not doing the random sampling, so you are generating the triples that you want to, that you suppose false, but you also do some random sampling in addition. And if so, what is the balance between the guidance of the negative triples and the random sampling that you keep? If I understood correctly, I'm not sure.
Yeah, so the random sampling, basically, you just take a positive triple and you just corrupt it, right, with any other maybe node. You basically take triple, you just change the head or tail. That's random sampling. But for the constraint-based sampling is basically, for example, the relation is broader, then you introduce another relation which is related. And that creates inconsistency.
And you experimented one or the other and not a mix of both approach.
Yeah.
That's what I missed. Okay, thank you.